All right, students, this is Chapter 9, Lecture 5. Again, Chapter 9 is titled Reconstitution of Powders or Crystals into Liquid Medication. We are going to pick back up on Chapter 9, Practice Problems B, starting on page 311. Again, you should have already read the chapter, reviewed the PowerPoint, and also have read the lecture notes provided to you. So if you're on page 311, Practice Problems B, it says answer the following questions and make necessary calculations as indicated. So for number 1, I'm going to start off. Number 1, you have oxacillin injection. Okay, I'm going to just pull out numbers and identify those numbers. So I have 1 gram. All right, that 1 gram identifies your total dosage. Okay, the next thing here, it says this vial contains oxacillin sodium equivalent to 1 gram and 20 milligrams sodium phosphate. It says to add 5.7 milliliters of sterile water for injection. So in detail, that 5.7 milliliters is the diluent volume. The sterile water for, let me write it correctly. Sterile water for injection, that's SWFI. In detail is the type of diluent that needs to be added. Okay. And it tells you that each 1.5 milliliters contains 250 milligrams of oxacillin. So this 250 milligrams per 1.5 milliliters is considered your what? Dosage strength. STRENGTH. All right. And just by looking at the information that's given, I'm going to tell you guys now this is a single concentration medication. And the reason why I know that is because there is only 1 dosage strength and 1 diluent volume. All right. So the first question asks us, what is the total dosage of the medication found in the container? Well, A is 1 gram. We've already identified that. The next question, B, what volume of diluent is added to this medication for reconstitution? Well, we've already identified the diluent volume is 1.7 milliliters. C says what diluent is used for reconstitution. Well, we've identified that too. The type of diluent is sterile water for injection. It says what routes of administration, the next question says what routes of administration are appropriate for this vial of medication. Well, if I read the label, it says for IM or IV usage. So for intramuscular or intravenous usage. The next question, which I'm going to label E, says what is the expiration time if this medication is stored at room temperature? Well, if I read on, it says discard solution. I'm reading to the right of the label under where it says read accompany circular. It says discard solution after 3 days at room temperature. So that's your answer, is that the expiration time for this medication stored at room temperature is 3 days. The next question F says, what is the expiration time if this medication is stored under the refrigerator? So if I continue on, it says, discard solution after 3 days at room temperature or 7 days refrigerated. So your answer for F is 7 days. The next question says, what is the total volume of medication after reconstitution? All right, I'm going to label that G. It's asking you, what is the total volume after reconstitution? Well, in order to calculate that, all right, the question is, what is it asking? Well, in detail, you guys, it's asking you to determine your final volume. Your final volume wasn't given to you. If you look back up, of all the things I've identified from the label, I've only identified your total dosage, your diluent volume, the type of diluent, and your diluent strength. All right? So the question for G says, what's the total volume after reconstitution? In general, what's the final volume? In order to calculate that, you have got to take, all right, this is the formula. You take your total dosage over the dosage strength in milligrams times the dosage strength volume, which is your milliliters. So let me show you what that looks like. My total dosage, you guys have already identified that as 1,000 milligrams. The dosage strength, you guys identified that to be 250 milligrams, and that volume that's associated to that dosage strength is 1.5 milliliters. Milligrams cross out. That means that once you reconstitute this medication, you're going to have a final volume of 6 milliliters. All right. All right. So we've calculated that final volume, which is considered the total volume after reconstitution, 6 milliliters. And how you calculate that is you take the total dosage over the dosage strength in milligrams, and you multiply it by that dosage strength of milliliters. So I took 1,000 milligrams over 250 milligrams and multiplied it by 1.5 milliliters, which gave me 6 milliliters. All right. Now I'm going to have to erase some of these so we can move on to the next couple of questions. But that's basically how we're going to be solving these problems. It's going to give you a label, and you're going to have to answer a series of questions that follow with that label. All right. So my next question, we're going to label that H. It says, what volume of medication is given for an order of 750 milligrams every 6 hours intramuscular? So basically, in detail, what it's saying is that the doctor has ordered 750 milligrams every 6 hours intramuscular. They want to know how much of this medication will provide that 750 milligram dosage. Well, you guys know that in stock, your dosage strength is what? 250 milligrams per 1.5 milliliters. So in order to solve that, calculate the dose, you have to do dose order over dose available times the quantity. All right. The dose order is 750 milligrams. The dose available is 250 milligrams. And the quantity that's associated to that 250 is what? 1.5 milliliters. Milligrams cancel out. That means that you calculate that to be 4.5 milliliters per dose. All right. All right, so next question. How many vials of medication should be prepared for a 24-hour period? All right. Well, if they are taking 4.5 milliliters per dose, and the order says every 6 hours, well, every 6 hours is technically how many times a day? 24 divided into 6 is what? 4 times a day? So multiply that by 4. That means that they are to receive 18 milliliters per day. Well, the question is how many vials of medication will be needed for a 24-hour period. Well, if they need 18 milliliters per day, and in each milliliter, or in each vial, there's 6 milliliters, you just divide it out. 18 milliliters divided by 6 milliliters equals what? 3. You're going to need 3 vials. Well, 1 vial will give you 6 milliliters. 2 vials will give you how many milliliters? 12 milliliters. And 3 vials will give you a total of 18 milliliters. And then the last question, let me see if I can fit it down here. J, it says, what is the powder volume? PV. Remember, PV equals FV minus DV. All right. Well, you already know that your diluent volume is 6 milliliters, or your final volume, your final volume is 6 milliliters. The diluent volume that you added to the container was 5.7 milliliters. If you subtract the 2, your powder volume is 0.3 milliliters. All right, so we have answered. That was just number 1 for practice problems B. Okay, I'm going to stop here for now. This is lecture 5 for chapter 9. We're going to pick back up. I'm going to give you some more practice problems that are not going to be found in the book. Your book has a lot of nice, pretty labels set out for you guys and pictured labels, but I'm going to actually start giving you word problems so that you can be able to solve the problems regardless of how the problem is presented. Because remember, however the problem is presented does not take away of the process of solving the problem. All right. So again, if you have any questions, please feel free to send me an email and I will answer them as soon as I can. This is the end of lecture 5. We'll pick back up lecture 6 with some additional practice problems.